Next, let me discuss the relation between the softmax classifier and also the logistic regression. Okay, so this is the example of softmax classifier. So suppose we have three classes like these, and then their own linear classification uh, coefficient as follows. And then suppose our input data has the feature value as 1 and 2 for the first and the second feature. And then, yeah, each of these y1, y2, y3 are computed as follows. And then from the neural net perspective, then we can represent it as these. So the first one is our input layer that is composed of x1, x2, and bias term 1. And then, let's see, in order to produce y1, the linear combination coefficient will be 2, -3, and 6. And for y2, it will be 3, 4, 3, 4, -1, right? And so it is 3, 4, -1, right? So once we obtain this linear combination output for each class, and then we have to pass it to the softmax layer. And then first of all, those values of 5, 10, and -1 will be changed into these values. So this is just a review that we already studied. And then we do the normalization as follows, so that they become all summing up to 1, right? And that way we obtain the probability value, right? And then we apply the softmax loss or cross entropy loss or KL divergence loss that we studied. Now I'm gonna give you the analogy from this softmax classifier to the logistic regression, where we have the two classes. Okay, so in the case of logistic regression, we consider like two classes, where the positive class or the negative classes are existing negative classes. Okay, and then given this linear combination output that was learned from the logistic regression, and then our final output will be mapped further through this sigmoid function, represented as follows. But let me rewrite this into this form by just multiplying e to the power of y. Okay, and then we obtain this guy, right? And then this 1 can be viewed as e to the power of 0, right? Okay, and then let's understand this logistic regression from the perspective of a special case of softmax. Okay, so we now have input layer composed of x1, 2, and 1, and then we produce this a single y corresponding to this positive class, right? Okay, and then it is further changed into EY, but for this 0, okay, for this 0, let's just create one virtual and additional node that has the value of 0 all the time. And then this 0 and this y value that is computed from our linear combination over here. Okay, those two values are competing with each other, just like this softmax classifier, where those three values are competing with each other so that they can have the as much probability as possible, right? And so here we have a single y and a fixed enemy that we compete against as 0, right, as a constant value. And then we just go through the softmax, and then they will be exponential, become e to the power of y, e to the power of 0, and then we normalize these two values, and then we obtain these values, right? Okay, and then this guy is actually positive class, and this guy is negative class. Okay, so that way this guy is the probability corresponding to positive class, and this guy is corresponding to the negative class. Okay, so in the case of logistic regression, it is viewed as a special case of this softmax, and we can also apply the cross entropy or KL divergence loss or the softmax classifier loss. So if y was 0, which is corresponding to this negative class, and then we have to maximize this probability, right? And then if you apply the KL divergence, then the probability, so the probability for our ground truth will be 1-up vector, where the probability of 1 is corresponding to this negative class. And then the loss function will be negative log of the corresponding probability value, right? And then if y is a 1, which is a positive class, and then negative log, and this probability value is coming from here, right? And so this is exactly the special case of this softmax loss, or cross entropy loss. And then you guys know that logistic regression has the loss function as follows, right? So this is just nothing but just an integration of these two cases where y is 0 or 1, and then if y is 0, and then between these and these terms, this one will be 1 and this one will be gone, right? And then if y was positive class, and then this guy will be 0 and this guy will be 1, right? And so this is exactly the cross entropy loss or KL divergence loss. And so this loss coming from this logistic regression is called binary cross entropy loss. Okay, so if you see, or if you played with the neural net or deep learning libraries implemented in Python, such as PyTorch or the TensorFlow, and then there is a function called the BCE loss or something like that. Okay, so BCE is representing this binary cross entropy loss. Okay, so that's it for softmax classifier and their laws, and also logistic regression as well. And this one has the mathematical connections to information theory that involves this entropy and cross entropy, and also the KL divergence and so on. But when you utilize them into deep learning, and then I think these knowledge or background is, I think, reasonably enough. And if you study a little bit more, and then I encourage you to study the information theory, which is another big subject.